So, thank you for the organizers again of this meeting, and Mario, and it's like the last time was 2 years ago. It feels like decades ago, years ago. So hopefully we're an optimistic time. I hope better. So I'm Tom. I'm from Tel Aviv, and my talk will be slightly different from the other talks, and you'll see in what way. So I am a basic scientist. I study the neural basis of value-based decision making. I have a lab that studies this. You know, even in 2020, we suggested a pathway in the brain about non-reinforced preference change with Lior Katz at the NIH, and mostly our research tool in the lab to study the neural basis of humans has been with an MRI machine. Okay, we have a very large imaging center at Tel Aviv. And actually, my entire career, that's what I've been doing. So like, I've been a basic, boring scientist. I try to persuade. That's my test if I'm able to induce, to those who know me, if I'm able to induce the feeling that I'm boring. But okay, so 2007, I studied the value-based decision-making of basic reward processing, putatively dopamine in fMRI with John O'Doherty. Then I moved to do my postdoc with Russ Poldrack, Craig Fox, risk and decision-making. And then in 2014, I did non-reinforced preference change, and actually that's when I started my lab at Tel Aviv. I spent 11 years working on this. And this is what I spoke about this decade of research. Then it was 9 years, then we just recently published a meta-analysis of those years. That's what I discussed last time. And also in 2020, we did a NARPS, it was neuroimaging of analysis replication prediction study with fMRI. Back then, Rotem Botvinnik-Netzer, now a faculty here in Jerusalem in psychology. Back then, she was a PhD student. We published it. So basically, this is to show that I've been doing basic research in humans all these years. And I didn't test when I came up with this slide, but this is actually the task that I presented last time, and I spent my whole time about this task that we developed for humans to change preferences without external reinforcements. And just recently, 2025, we published what we think is finally the mechanism. And this is the types of tasks we've been using in our labs to study basic human behavior. And in this task, what people see, this is a demo of the task. So images are presented on the screen, one by one, for 1 second, and then for some of the items, there is a neutral cue, a beep, and then they need to press the button as fast as they can. Okay? So, I spent, as I said, 10 years on it in my lab from my postdoc, and still I have a PhD student here still working on this now in a retired PhD. But these are the types of labs, the tasks we've been doing in the lab, controlled. In the lab, we have an eye tracker here that follows behavior. We can model this behavior with Bayesian computing and models, etc. It's very, very controlled, right? An item is shown on the screen. Participants sit in an experiment room. This is what they do. We can do it also in the scanner with their eye tracking. Very controlled basic research. But then, 8 years ago, my students in my lab, they told me, and actually I showed this last time as well, which is pretty funny that I'm actually continuing my talk from 2 years ago, although it's been a lot that's passed on our brains. So my students told me, because my lab is called the neural basis of behavioral change, they said, well, behavioral change is performed outside the lab, in the real world, so of course we have to have virtual reality. Okay, so back then I argued with my students. I don't anymore, asked them. I don't anymore. But then I said, okay, I don't understand really the connection, but okay, you guys want me to buy virtual reality. They told me it doesn't cost a lot, $500, but the computer is $5,000. Fine, I did it, I bought it. And then they designed this task, this version. So this was a demo in Unity. It's a spaceship that basically shoots on the snacks that you just saw. Okay? So there's a beep and a button press. Now, this has never been run. I never ran this study Because when they showed this to me, I said, oh, no, 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 no. I'm not a virtual reality researcher. I don't do this, and this is not controlled, right? Because they're not looking at the items at the center of the screen, right? They're not looking at it, the fovea, and they're moving. How will I be able to control all of the variables? Okay, so I've never ran this. I've actually, back then I didn't do any studies. Fast forward 8 years, I think that actually virtual reality is a great basic research tool, okay, to study simple value-based decision-making problems. And in the context of this conference, actually when we're thinking about more naturalistic and relevant stimuli, it's actually great for that as well, because we have a control of the entire testing setup and what participants are seeing, and I think we're building a system for you guys to use. So when I say basic controlled research, and during the break you guys can do the demo, you see images here. This isn't virtual reality, but these are 2D images. So right now we are doing studies in my lab with 2D images in virtual reality. So many times the image of virtual reality is that complex 3D systems, and also if you talk to people, it's not a new system, okay? And when you talk about people commercially, this has been a total flop. But I don't care about, Meta or whatever. I care about my research lab in this context. I don't own one at home, okay? So I'm not a gamer, I don't have a VR headset at home. And this is the basic research we are doing in the lab, binary choices of 2 images. But what you're seeing, and this is from the demo, what you can see is actually, the headset that I'm talking about right now collects multiple types of data. Eye tracking, hand tracking, and face tracking, all in one headset. So I can perform basic research, binary choices, and it's collecting a lot of data. So basic controlled research in virtual reality. Okay? So this is basically now the output of an experiment. But now, so they come to the lab and they do it in the lab, in a testing room, while they're wearing the headset, but just to collect all these types of data. So eye tracker, sure, we have it. A hand tracker? Sure, motion labs, motor control labs, they have cameras for the hands, but in value-based decision making, but actually when you think about it in the world, we reach out to things, we want to do it, so there's a lot of data there. Face expressions, I don't want to have the faces of people coming to my lab, but here I get the muscles. So basically, virtual reality, right now we're using the Meta Quest Pro. Okay, it's $1,000. Actually, it's less. Okay, now on Amazon you can get it for $800. Why? Because commercial companies have gotten into this field and they're offering us a very cheap research tool. They don't care about us. Okay, there's no research support. But a laboratory research eye tracker from iLink cost me $40,000 to get 1,000 hertz. But here it's 72 hertz, and I get eye tracking, hand tracking, and face tracking. Okay, everything is digitized. Everything is digitized. Now, basically, I'm coming to talk about this in our conferences and here because in the past few years, now I guess like a third of my lab is doing it under the ERC that we have. But we are now in the process of actually building an open access tool, a platform that everyone can use. So basically, if you're a student now, if you have students or if you're a student right now and you don't know how to code, it's actually not true. You know how to code, okay? There's vibe coding, you can talk to chat, everybody knows how to code. And if you don't, you need to do it, okay? So my students right now, what they're doing, we are building now, okay, this team right now. So Noah, she has a computer science degree, also with the design from Betzalel here, but all the others, Yuda was my master student, you'll see what he did. Omri works in our facility, also a master student, previous one, and Galia, she just finished engineer. So we are building now a whole open testing system from the level of building experiments, like you see in the demo, to QA, validation, and data cleanup. So at the end of the experiment, you get the same types of data. Behavior, choices, reaction time, but also eye tracking, hand tracking in a very simple way. Now my example for how we started is Michal, my almost former PhD student. So she started And the study was, published after, then it took time after COVID. We thought things were complicated back then. Back then we worked with HTC, so I don't care about the company, okay? I have no conflict of interest. I don't get any money from any one of them. Back then we worked with an HTC Vive headset. Then we had to send it to Sweden to Toby to install an eye tracker for 10,000 euros. Okay, that was the case in 2021. And Michal worked only in the testing room that we had, standing up. And already then she did what seemed like naturalistic. Okay, this was very level basic graphics. Or so everything is, Gen AI is now finally working through 3D, but it's available. Everything is available and affordable. So she used this scene, and what she did, she wanted to study the link between eye tracking and preferences. Okay, so participants came to the lab, and they put on the headset of the VR, and they had animals and shapes, and this is what they did. Now, this is a very basic experiment. Okay, basically, actually, in recent years, if you go to conferences, VR conferences, many people use this scene, okay, that you could download for $15 from the Unity store. So what Michal did, what you saw, people, all they did was look at the jumping things. Now, when people come to the lab, it doesn't make sense to do this simple experiment, but in VR, they actually liked it, which is nice, because when we test humans, not only with very artificial stimuli, we also test them in our, what are you doing? But here, no, really, you're paying me to stand in VR, which is really funny, right? It's not you. So all they did was watch items. I'm interested to understand how people construct values of items, and we recorded eye tracking on these jumping up and down items. But then, after the experiment ended, for the first time, we asked them now, how much do you like each of these items? For the first time after the experiment, so we could separate out something very artificial about looking at items and then how much do you like them? And then they told us how much they liked them. And the idea here is to see, can we find something in the eye tracking of individual items, of how they process them in the world. The name of my ERC is passive value markers, no choices. Okay, and we had, so this is how the experiment looks like. They stand and they look at these items, and then we had pairs of items in the scene, pets and shapes. Okay, and then we asked them, how much do you like the items? And of course they preferred the snacks, the pets. Sure, why wouldn't they prefer the pets? It's not interesting, okay? But then we calculated multiple measures of eye tracking, okay? So we record the eye tracker on the eyes of the participants. I want to say unbeknownst to them because they know we're recording it, okay? But the recording is passive. Eye tracking is not passive, but the recording is very basic, okay? It's very simple to do it. So we recorded multiple measures of eye tracking. And what we found is this finding. Is actually, if we look at the measures of this eye tracking, okay, of the median scan speed, how fast do they scan the items, we found a correlation between this basic measure of eye tracking, okay, we collected the pilot sample, we tested it, pre-registered, and preferences of individual items. And in a way, so this doesn't work in 2D in the lab. And we're trying to figure out why doesn't it work with the 2D in the lab, that just a simple feature of eye tracking correlates with preference. There are many different things here in this experiment. First of all, there's context. And then you look at individual items. Well, which, by the way, so I mentioned Lior Katz, who studies monkeys. So monkeys, for them, to show the way we show very artificially items in the lab in 2D, in the background of a black screen, nobody does a monkey experiment like that. Why is that? Because monkeys nothing in the world looks like that. Okay? We have a background in the world. So in a way, all the experiments that we took from animals, that's the way I grew up, on dopamine, etc., actually monkeys' experiments are much more naturalistic even in the lab. They show 1 on the background, 1 divided by f. That's like the general frequency. So in the 2D, why doesn't it work? Because it's 2D, because it's more artificial. So now we're trying to figure it out because in the lab, the eye tracker is much better. So then Michal wanted to move from this testing room, the 2D or just standing, to do a walking experiment. So we actually started a center, a university center, which basically all it has is space. Okay, the thing that we're lacking most is space that we can do walking experiment. Okay, I'm sure here in Jerusalem you have space. And this is, we have 50 square meters of space that we can do experiments while walking. And we also have a studio that people can build experiments if they want to purchase it, just like a university resource. Doesn't matter, but you can have it in your lab or do it from there. And then Yuda, who did a master's together also with Pablo Blinder. So Pablo Blinder, I'm in neurobiology. So he studies animals and mice, and I guess you know the study about aha learning by Meister, and insight learning about mice. And Yuda said, okay, I want to do it in humans. Do it in humans. How do you study navigation in humans? I don't have a big warehouse to create a maze. So we did it in virtual reality. So we took the arena, and this is a maze in an arena of 5 meters by 4 meters. You can create a very complicated maze. Okay, people can get lost and really upset, by the way. Okay, and you have to titrate it. So this is what Yuda did. He ran this experiment, and people walk in a maze. So you can say, wait, this is very artificial. Because you see, this is a very simple visual stimulus. But they actually never, 50 participants never went through a wall. And you can actually induce real world exploration and navigation. And I'll show you how we can make this naturalistic. Okay, and Yuda did this. This is our arena. And he had this maze, and you can analyze it just like you analyze the data in mice. This is we have a pilot, and now we're collecting the pre-registered full sample. So you can actually make humans actually navigate, and you can collect all this data. Eye tracking, face tracking, hand tracking, and of course, location in space. Everything with this headset that I just, brought here. It's a mobile research laboratory. Okay, so Yuda found, these are preliminary, this is from his poster in a lot. Also humans, they experience this aha moment. Okay, so they start walking. Okay, this is a trial number. As the learning advances, their time takes less, and we have questionnaires that we ask them. So basically, this is just to show that we have a basic type of behavior. We can do spatial navigation, space exploration. Think about cues that you can add here. Also, again, in the context of addiction, we think about how can we do it? They're very much engaged. Okay. So just a few things we can actually do with this technology. This also, so it's called XR, extended reality. It stands for virtual reality, augmented reality, and mixed reality. And this is an experiment now that Maya is doing. So she also looked for ways to induce learning or ideas of habits in humans. So in my lab, we previously used, during COVID, we did smartphone applications. So it's really hard to induce habits in humans. Really hard. We have like repeated failures, I guess, from my master's degree with Daphne Joel, and then I have a PhD student, Rani Gera, who failed with an app, and now he's doing it with John O'Doherty. I hope he's not failing. So Maya also, it didn't work for her with an app. So then she turned to do more realistic stuff with actual items. So right now she's comparing responses to actual stimuli versus 3D stimuli. This is an augmented reality. So if you do the demo in the lab, and if you do the demo here, your background and context will be here. This is done in my lab, Tel Aviv. So they're choosing, this is virtual content, okay? This is virtual content that they're choosing, but in a realistic context. So think about all the cue elicitation that you can do in the term of addiction. You can run an experiment, actually in someone's home, okay? Back then, Maya thought about inducing habits. Now she's not doing any more habits. I guess if any habit researchers here, it's really hard to induce habits in humans. It's a different topic. In the lab, I mean, we all... Okay, so augmented reality. It's another thing this headset does, and you can do a control experiment while collecting all these types of data with stimuli that are digital or not digital, in someone's real environment, or actually take a video of their environment and bring it to the lab. So I like to say that it's a basic research tool, but very easily you can have a naturalistic environment that you induce. And I showed you what Yuda does, but this is in the demo. You can do a maze here. I tried it. I didn't fall down because you can define the area. And you can do a maze. while you're walking here in a 2x2, and you can collect location, eye tracking, hand tracking. So a lot of data with this simple tool. And now also naturalistic but controlled. So Yana, my master's student, she did a museum tour. This is from the demo. She used a more complicated version because at the time he wanted to do an actual experiment of exploration in a naturalistic environment in the actual museum. But you know, during a war, they take down the pieces and put them in the basement. So because she was a student, she had to finish her master's. So she brought it into VR. But now, and now hopefully we'll run the study, not with Yana, but now in VR, you can now see the location of how they walked. We have narration. We have eye tracking of looking at the items. So the experiment is very different than actually running it in the museum. Because in the museum, if you want to have eye tracking, you have to put glasses, etc. So it's a different experiment. But in VR, you can collect all of these data, how much time you spend, eye tracking, how they did. Okay. So at the end of the demo here, you'll be able to see we also have something that showcases the technology. So again, right now I'm trying to make this a community project for the community of people who want to do basic experiments or experiments in VR, but in a simple way. So you can experiment all the different measures it collects, but you can see here that it also, we can take now the 64 facial muscles that this headset gives us. So every headset is slightly different. And now Hadar he was a research assistant. He has an undergrad in physics. Now he's continuing to do a master's in astrophysics. But he did this simple calculation, and it can now identify emotions. Okay, so very basic, simple way to study all of these different measures. Okay, so I'm suggesting that XR now, I use it in my lab. There are multiple labs now around the world that are starting to use it. There have been many labs that have used virtual reality. There were virtual reality labs because they had a lot of money, a lot of resources to invest in creating the codes. And we are trying now, I mean, we're already showing it, that we can do it. But now we're trying to take a few people together and use it. Graphics are really, are becoming a very easy solution. And the idea to use it, we have a Minerva Center. It's a collaboration with Germany. So if you're a lab here, if someone here, you have a collaboration with someone in Germany, we're allocating funds every year for these collaborations or traveling. And if you want to use these codes, email me. And I want to thank all of the lab that's been doing this for all this year for pushing me. And I never argue with students anymore. Okay, thank you very much.